This video is the first in a series of 3, which explains how Accanto StratOSS achieves 100% service lifecycle automation for next-generation services. In this edition, we will demonstrate how Accanto's StratOSS platform, and in particular its Intent Driven Orchestration capabilities, fully automates the operational lifecycle of network services. In order to explain where this part fits, let's recap on what we're trying to achieve overall. The amount of manual effort in operating complex network services increases exponentially with the use of traditional OSS systems. Automation of the operational lifecycle, not just the onboarding and design, has become essential to make the model commercially viable. The greater the operational automation, the more efficiencies. Once live, the operational maintenance of a service is proportionally the largest percentage of the cost and effort. It is here where StratOSS outperforms traditional OSS, reducing manual effort 30 times more than with traditional systems. There are 3 elements required to achieve 100% operational automation. First, intent-driven orchestration fully automates the operational lifecycle of a service without the requirement of manually scripting program code. This offers a cost reduction not only in manual labor, but also in the level of skill required. Second, integrated DevOps-enabled service behavior testing reduces the number of errors in services before they go into production. Fewer errors means less manual effort to diagnose and resolve issues. StratOSS fully automates the spinning up of test or pre-production environments, instantiating services, and necessary monitoring and test resources before running automated tests that run through the full service lifecycle. Third, AI-powered diagnostics. On achieving 80% operational automation through the use of intent-driven orchestration and integrated service behavior testing, production errors may still occur. Artificial intelligence can then be used to automatically diagnose and resolve issues that would normally require human effort. When you are operating services based on a large number of virtualized resources, traditional OSS tools require you to manually program each lifecycle for start, stop, heal, scale, upgrade, etc. This needs to be done for each VNF, but also for each network service that may consist of tens or hundreds of VNFs across multiple data centers. This simply becomes too complex to manage and will lead to a massive operational cost. With StratOSS, the only thing you need to write scripts for are the primitive lifecycle steps for VNFs, including install, start, configure, stop, and uninstall. It is important to force all resources, like VNFs, to follow the same unified lifecycle model, as this is the key for the intent-driven orchestrator to enable automated service lifecycle management. When this is in place, the advanced lifecycle actions such as heal, scale, upgrade, and both the primitive and the advanced lifecycles for network services are fully automated by the StratOSS intent engine and require no further manual effort. StratOSS automatically calculates and executes your network service from its current state to its intended state, taking into account all the dependencies and the relationships between the VNF and the components. Once the services are in production, this means a significant reduction in operational maintenance effort, as the intent engine brings the network services to their intended states without any manual programming. Let's show StratOSS and its intent engine in action. In this scenario, we are demonstrating a voice service. I'm logged into StratOSS and I'm going to instantiate and put into active state a new network service. I select the right network service, can add some properties, and hit create. The intent engine then takes over and executes the intent. It has figured out the current state of the service and knows the intended target and what resources are needed. What you see here is that the intent engine has calculated and is executing the best path to get the service from the current state to its intended state. It is doing so by running all components through their required life cycles in the right order as described in the Network Service Designer, and running an integrity check at the end. You can see here that it's going through the installation, configuration, and start life cycles to bring each resource into an active state. Now, this is a very simple service, but imagine when you have hundreds of complex network services with tens of data centers and hundreds of VNFs. The amount of manual effort that is required just to instantiate these services is enormous, but StratOSS fully automates this process without any manual programming. As you see here, the intent is finished and the voice network service is active. The next step I want to show you is the intent engine and its automated heal capability. I'm going to manually remove one of the Kubernetes pods where the voice server has been installed to simulate a component that is broken. Once this is removed, and I go back to StratOSS, it automatically recognizes that there are no more health metrics being received from the voice server, and the intent engine will attempt to heal the service that you can see here. We have a feature called Complex Heal, which will first try simply to stop and restart the VNFs, and if this does not work, as you can see here, it will move to stopping, uninstalling, and reinstalling the broken components. It is important to understand that the intent engine heals only the broken components, i.e. it is aware of the current state of the network service and only fixes the broken components while leaving the other components in place, and only then re-establishing relationships to these existing components if needed. Again, the StratOSS intent engine has gone through a full automated heal, detecting the broken component and healing this without any manual programming or intervention. The final part of the demo shows StratOSS performing an automated scale-out. In order to show this, I will instantiate a traffic generator resource that will start to place calls through the system. You can see the intent engine going through the lifecycle of the traffic generator in order to install, configure, and start it. Now, if I look at the StratOSS UI in the meantime, I can see that no traffic is flowing yet. Once the traffic generator has been successfully started and starts to make voice calls through the service, you can see this in StratOSS with the green lines that are appearing that indicate that traffic is flowing through the network servers. Since the amount of calls we are generating is higher than the threshold that has been set, StratOSS will detect this from the continuous metrics it is gathering. StratOSS will then automatically execute a scale-out for the needed components, in this case to add another voice service. And this is what you see here. You see the intent engine carrying out the scale-out. You see the additional voice server appear in StratOSS on the top. The intent engine installs, configures, and starts all the required resources in the right order, and also re-establishes any relationships that are required. For example, in this case, it will add the newly created voice server to the dispatch list of the gateway, so that it is ready to receive calls to handle the traffic. This is all done automatically by the intent engine, without any manual programming that was required to perform any of these actions. Once the intent is completed, we can now see the operational service with the additional scaled-out voice server in StratOSS handling the traffic. As a conclusion, in order to create commercially viable NFV solutions, the traditional OSS systems do not provide enough automation. In order to significantly lower the operational costs for NFV services, a much higher degree of automation is required. 3 elements are needed for this: intent-based orchestration that enforces brutal automation of the entire lifecycle of these services to remove manual effort in designing and especially in operating the services, an inbuilt service behavior-driven test to fully automate service testing and reduce the amount of errors of services that go into production, and thirdly, when things do go wrong, AI can be used to trigger diagnostics and automatically resolve issues. These 3 elements combined in StratOSS enable a significant operational automation and have been shown to deliver over 30 times more operational efficiency than traditional OSS systems.